Hey guys, welcome back to Chapter 4. We're going to be continuing on with 4.4, Conditional Probability and Independence. The probability of an event A given that event B has occurred is called the conditional probability of event A given B. And that's denoted as this. So that is pronounced A given, that line is a given, B. Further, the probability is defined as this. That's the probability of A given B is equal to the probability of the intersection of A and B, or probability of A and B, all over the probability of B. Likewise, probability of B given A is equal to the intersection over the probability of A. Independence of events. Two events A and B are said to be independent if and only if the probability of A given B is equal to the probability of B. And that's to say that, like, if B has occurred, did it affect A? And if the probability of A given B is the same as the probability of A, then clearly no, B having occurred didn't affect A. That's the idea behind independence, using the conditional probability and equating it to the probability of A. Where both probability of A and B are greater than 0, yep, that's true. And this is equivalent for the other way. The probability of B given A is equal to the probability of B. I would go ahead and add in another rule there. And then this would just be a check for independence. And this check for independence would be the probability of A times probability of B equals probability of A and B, the intersection. And I put a question mark there. So this is basically saying that the way that we check for independence is that if the probability of A times the probability of B equals the intersection, then independent. I know I missed some letters there. Independent. We'll see that in some problems here in a second. And then we move on to the multiplication rule. Don't let all the letters scare you here. This multiplication rule is just exactly our conditional rule that we just looked at. This rule. So the conditional probability, so probability of A given B is equal to the intersection of A and B divided by probability of B. If we go back here, I guess I'll write it right here. Probability of A and B is equal to the probability of A times the probability of B given A. And if we just divided the probability of A out of this, so we just divided the probability of A out of this, it would be the probability of A and B all over probability of A is equal to the probability of B given A. And that's our exact formula from down here. So this whole thing, and then I guess don't mind this last part. This last part is the same thing. Also, they're just combining the two formulas together. All this is saying is this multiplication rule is just using this conditional probability rule, either one of these, because they're equivalent. We're just talking about two different events. Just using that and rearranging the terms to solve for the probability of A and B, or the intersection. Okay. And then this is just the rule that I noted before. If A and B are independent, then the probability of A and B will occur. The intersection is equal to the probability of A times the probability of B, or the probability of B times probability of A, all the same. And then furthermore, for n independent events, so not just two events, so this is just for two events. And this is just takes it up to n number of events. And this would just say that the intersection of all those events right here, that's the intersection, is equal to all of the probabilities multiplied together. That's all that means. Okay, let's look at our worksheet. We're going to look at problem 2. Wrong one. Problem 2. Using the above table, so this will be the table that we just used in the last video. Find the proportion of MasterCard holders who have Visa cards. Interpret and write this proportion as a conditional probability. So this is where the wording gets pretty dicey, I guess. What the mind wants to do whenever you read this, you want to turn this into like an and, M and V, so MasterCard and Visa card. But that's not actually what's going on. So it says find the proportion of MasterCard holders. The word of is very important. Of MasterCard holders who have Visa cards. So I could word this differently. I could say find the proportion of or find the proportion who have Visa cards given that they have MasterCards. And that means the exact same thing. So we would write given M V. So that's what that would look like. Find the proportion of MasterCard holders. So given that they're a MasterCard holder, the probability that they are a Visa card holder. That's an arrow, not a T. And so then we would write down our formula, and that would just be the joint probability or the intersection. That's V and M, probability of V and M, all over the probability of M. So these are numbers that we have already calculated. I'll let you guys scroll up if you want to scroll up, but it's just too hard for me to scroll back and forth. I'll just look at my notes here. Uh-oh. It's 1,000 over 2,500. Excuse me, and that is 0.4. So this is given that the person is a MasterCard holder. So given that the person is a MasterCard holder, the probability that they also have a Visa. So we would look at the 2,500 here and the 1,000 here. And it's going to be 1,000 over 2,500, essentially. 1,000 over 2,500. So essentially we would be like disregarding everything else in the table that doesn't have anything to do with MasterCard. So once we say given M, that's kind of what we can do with the whole table, right? So we would just be looking at that top line. And so then our total is 2,500. And then the people that have a Visa are 1,000. And that's it. So then similarly, so that was part A. So then for part B, it says find the proportion of Visa card holders who have MasterCards. So given that they have a Visa, what's the proportion that they have a MasterCard? So given that they have a Visa, what's the proportion that they have a MasterCard? So this formula we know as the probability of M and V, right? Which is just the probability of V and M. Those are interchangeable, but we'll write it just so that we don't get confused. All over the probability of V. And that's going to be 1,000, which, like I said, M and V is the same as V and M. So it's going to be the same 1,000 over the number of people who have Visa cards. So we scroll back up. And the number of people who have Visa cards are right here. So similarly to last time, once we say given that they have a Visa, we can just focus in on this column right here and just get rid of everything else in the table from our thought process. And so then it would just be 1,000 over 4,000. or 25%. So then lastly for this question, are the events having a MasterCard and having a Visa independent? Justify your answer. So independence, like I said, the easiest way to answer the independence question is when we multiply their marginal probabilities together, do they equal their joint probabilities? That was the formula of, I'll just go ahead and sub in m's and v's here. So we'll say probability of m times probability of v, and then question mark, does that equal probability of m and v? Okay, so we have all these numbers. We've calculated all these numbers before. And we know that probability of m is 0.25. Probability of v is 0.40. And the probability of m and v is 0.10. So we go ahead and we multiply the left side of this, and 0.25 times 0.40 is in fact 0.10. And those do equal, so we say yes, independent.